Welcome to this introduction to normal distributions in social work research. The normal curve is one of the most fundamental concepts in statistics, helping us understand patterns in data, make informed decisions, and evaluate interventions effectively. In this session, we'll explore why the normal distribution matters, how it applies to social work, and how we use it in research and practice. Let's get started. In this session, we'll cover the basics of normal distributions, including the normal curve, skewness, standard deviation, and probability. We'll also discuss why understanding data distributions is essential for social work research and practice. Let's begin. The normal distribution is the fundamental concept in statistics. It is symmetric and bell-shaped, meaning the left and right sides mirror each other. In a normal distribution, the mean, median, and mode are all equal and located at the center. Many real-world social work-related factors such as income level, stress scores, and mental health assessments follow this pattern, making it essential for research and data interpretation. Not all data follows a perfect bell curve. However, sometimes distributions are skewed, meaning they lean to one side. A positive skew happens when the tail extends to the right, like income distribution. Most people earn less, but a few high earners pull the average up. A negative skew happens when the tail extends to the left, like retirement age. Most people retire around the same time, but a few retire much earlier. Standard deviation measures how spread out the data is around the mean. In a normal distribution, most data points cluster around the center, and fewer appear as we move further away. 68% of data falls within one standard deviation of the mean. 95% falls with two standard deviations. 99.73% falls within three standard deviations. This pattern, called the empirical rule, helps us predict probabilities and understand variability in data. In social work, it can be used to analyze trends, like how stress levels or income distributions compare to the average. Kurtosis tells us about the shape and peak of a distribution. There are three types. Mesokurtic is when the distribution has a balanced normal shape, meaning data is evenly spread with moderate peaks and tails. Leptokurtic is when the distribution is tall and narrow, meaning more data is concentrated near the mean, with extreme values occurring less often. Platykurtic is when the distribution is flat and wide, meaning data is more spread out, with fewer values clustering around the mean. Again, data doesn't always follow a normal distribution. Different data sets can take on different shapes. Normal is when the distribution is bell-shaped, like here, meaning most data clusters around the center, like IQ scores or height measurements. Bimodal is when the distribution has two peaks, meaning data is split between two common values, like contrasting opinions in social research. Rectangular is when the distribution is uniform, meaning all values occur at roughly the same frequency, like rolling a fair die. In research, we often can't study an entire population, so we use a sample, a smaller group that represents the whole. Population is when we study every individual in a group, like surveying all social workers in a country. Sample is when we study a subset of the population, like surveying only 200 social workers, to make broader conclusions. Since samples don't include everyone, there's always some level of error, but using proper sampling methods help us make accurate and reliable inferences in social work research. When we use a sample to represent a population, there's always a chance that the sample doesn't perfectly match the whole group. This is called sampling error. The best way to reduce sampling error is to use random sampling, which helps avoid bias. However, even with random sampling, some error is unavoidable because we are only working with a portion of the population. In research, chance refers to random variation that can affect results. This is also known as sampling error. Probability measures how likely an event is to happen, which helps us predict outcomes in research. Inferential statistics use probability to make conclusions about a larger population based on a sample of data. A parameter describes a whole population, like the average income of all social workers in the country. A statistic describes a sample, like the average income of 200 surveyed social workers. Since we usually can't study an entire population, we rely on statistics to estimate parameters and make informed decisions in research. When we conduct research, we usually can't study an entire population. Yes, so we rely on samples, but how do we know if our sample represents the population accurately? This is where theoretical sampling distributions come in. A theoretical sampling distribution is the normal distribution of all possible sample statistics, like sample means drawn from the same population. Here's what's important. The mean of the sampling distribution is equal to the population mean. The spread, called standard error, gets smaller with larger samples, meaning bigger samples give us more precise estimates. Thanks to the central limit theorem, even if the original data isn't normally distributed, the sampling distribution will become approximately normal as more samples are taken. Z-scores are powerful in social work research because they help us standardize scores, compare different data sets, and identify outliers, making data analysis more accurate and meaningful. A Z-score tells us how far a value is from the mean, measured in standard deviations. A Z-score of 0 means the value is right at the mean. A positive Z-score means the value is above the mean, while a negative Z-score means it's below the mean. Throughout this presentation, we've explored key statistical concepts like Z-scores, normal distributions, and sampling distributions. But how do they connect to social work? In practice, these tools help us assess risk, evaluate programs, and inform policies. For example, Z-scores can standardize mental health assessments, making it easier to compare client symptoms to clinical benchmarks. Normal distributions reveal trends, like whether income levels or stress scores follow typical pattern in a community. Sampling distributions allow us to generalize findings from research studies to larger populations, ensuring data-driven decision-making. By applying these concepts, social workers can strengthen assessments, improve interventions, and advocate for systemic change based on solid evidence.